Hello and welcome to the world of Weihenstephan Standards. My name is Romy Ries. I'm working at the Technical University of Munich, and today I like to introduce you to the Weihenstephan Standards and our current project WS Sweets Weihenstephan Standards for transparent and efficient confectionery production. If you have a confectionery production line, you probably also have a wide range of different specialized machines from different machine manufacturers. If you want to connect these machines now to a higher level MES or IT system to use all the nice functionalities of MES like KPI calculation, reporting, batch and article tracing, process visualization or quality and energy management, you have of course connect all these machines to this higher level IT system. However, due to the lack of standards for communication and standardized interfaces, it's quite difficult, it's time consuming and it's cost intensive to connect all these individual machines. The same you have when you want to connect the machines to each other, maybe for decentralized line control or M2M communication. Here the Weihenstephan Standards can support you with a standardized interface for the food and beverage industry. The Weihenstephan Standards provide easy to implement communication protocol, WS OPC-UA, which is based on OPC-UA. The Weihenstephan Standards provide over 440 uniquely defined and practice relevant data points for machines of the food and beverage industry, which enables you to use or to calculate and use all the relevant MES functionalities. And furthermore, the Weihenstephan Standards have industry-specific recommendations for data evaluation and reporting. Let's take a closer look to these three aspects of the WS. Let's start with the domain-specific recommendation for evaluation and reporting. If you want to calculate your OEE, you need the parameters, the planning efficiency, availability, performance efficiency and rate of quality. In the Weihenstephan Standards, in the part of evaluation or recommendation for evaluation, it is written in detail how to calculate, for example, the availability and the other parameters. So here, for example, it is written in detail which data point you have to use to get at the end the operating time or the loading time. So here in this case you need the data point V is current proc, so the current program, the V is current state, the operating state of the machine. The other way or the other aspect of the Weihenstephan Standards is the data content. So these are the data points. We have, as I formerly said, over 440 uniquely defined data points in our Weihenstephan Standards. So here's just a screenshot, but when we go in detail, these are the following points which are totally or uniquely defined VS data points. So we have the browse name, we have the WS display name, the category, the tag number, which is only necessary for VS protocol. We have the description of this data point, and we have more details, for example, details for implementation, so advices. We have the access permission, the data type for WS OPC-UA and the data type for WS protocol. The other things, the other aspects of the data content are the machine classes. So as you can see here, these are the machine classes which are defined in the domain WS pack. So you can see here all the machine classes, and we have these also for the other domains. So for the WS food, WS bake, WS brew and WS sweets domain. And last but not least, one point for the data content is the permutation table. It's also domain specific, and here you can see which data points which data points are mandatory for a machine, or which data points can be optionally provided of a machine. The third aspect is the communication. So for communication in an Industry 4.0 environment, the Weihenstephan Standards relies on OPC unified architecture. The OPC-UA is an information-centric layered architecture with following core aspects. OPC-UA brings all points, all aspects of security out of the box, so you don't have to think about these. OPC-UA is platform independent, so you can use it nearly on each device you want. It is vendor interoperable, it's object oriented, and it enables a comprehensive information modeling. So all in total is OPC-UA much more than a protocol. How do we use OPC-UA with WS OPC-UA? So at the end of the day, we want to have an OPC-UA server instance of our WS machine. So at the basement of every server instances is, we use the meta and information model of the OPC Foundation. On top of these, we can use already existing companion specifications. So for example, the companion specifications for machinery and companion specifications for devices, and also the companion specifications for PAGML, which we use for our state machine. On top of these, we have our companion specifications, so the companion specifications for Weihenstephan Standards. Inside these companion specifications, the data points are not included here, but it's included the data types and the way to structure our machines. So which functional group folders are included or it's expected on this OPC-UA server instance, but no certain data point. The gap between our companion specifications for Weihenstephan Standards and our information model is covered by our WS templates. So in here, I formally showed it, is exactly defined which data point applies for which machine, and the definition, the complete definition of the data point are inside these WS templates. Yeah, let's have a look on our current WS Suites project. So what was the goal of the project? Based on the Weihenstephan Standards, an interface standard for the confectionery industry was to be developed that provides all informations for simplified and cost-effective MES connection and M2M communication. We worked together with different industry project partners. So we had here confectionery manufacturers, we had machine builders, and also companies for IT integration. What have we done in the project? So our first step was to identify the relevant machine classes. So as we have a lot or a wide range of different confectionery products, we had to focus on certain reference products, and we decided together to focus on the production of chocolate tablets, jelly products and bars. So in this case we focus on the machines for these for production of these three products. The second step was to identify the relevant MES and IT functionalities. So here it was quite important for us what are the needs of the customers or the needs of our confectionery manufacturers. So for example, do you want to calculate KPIs or process visualization, batch and article tracing? All these functionalities were gathered here. From these two things we were able to derive the relevant data points for each machine and create also the permutation table, so what I formerly showed the data point machine assignment. And from this now we can write our recommendation and evaluation PDF document. So this is the recommendation with the examples of how the informations can be generated and presented using the WS data points. That's it from my side. Tobias Vogt will now show you our simulated demonstration plant. This simulated chocolate production line was our first implementation of the new WS information model, and it shows the advantages of a standardized network connection based on WOPC/UA.
Welcome also from my side to our WS Suites video for ProSuite Cologne. My name is Tobias Vogt and I have the honor to present the WS Suites demo implementation to you. This is based on a virtual chocolate bar plant shown here in a simulation. Some of you might already know this from the preliminary ShowConnect project, and we used this demo again, thanks very much for that, with our partners Teegarden, Pactec, Solix, Siemens and Winkler & Dünnebier to update it with the results of WS Suites. The virtual plant was chosen with the machines a temper from Solix, a molding plant from WDS, a buffering system and 2 packaging machines from Teegarden and Pactec to show how the WS Suites interface may be implemented in practice, and also to give an idea of the opportunities that WS Suites provides to you. Those virtual machines that of course could in the same size and same functionalities exist in reality are controlled by programmable logical controllers, of course. In this case, for the demo, we also used simulated programmable logic controllers. We used the software PLC Sim Advanced from Siemens and realized 5 controllers, 1 for the tempering machine, 1 for the molding plant, 1 for the buffering system and 2 for the packers. And on this controllers, Simatic S7 1500 family, our machine building partners realized their programming code. Those controllers are connected via an internal interface with the simulation environment, that is plant simulation, also from Siemens. And as with a real machine, those controllers control now the material flow of the simulated machines. To realize the WS Suites interface based on the OPC/UA companion specification for Weihenstephan Standards, on all of those controllers OPC/UA servers have been implemented. To do this, you use the standard OPC/UA server functionality, in this case provided by Siemens, but of course this could also be controllers from other companies, Allen Bradley, Schneider, etc. Many others also provide OPC/UA server functionality already. Then our machine building partners got node sets, OPC/UA node sets according to WS Suites, and by importing those into the controller, they already had realized the OPC/UA server interface with all the necessary data objects according to WS Suites, of course. After that, they had to map those interface objects to the program variables of the controller program. This had to be done by the machine programmers, and after that, those machine controllers were visual, and you could be connected via the OPC/UA server. Also, on all of those controllers, OPC/UA clients had been realized. This allows bidirectional communication without any central station above from machine to machine. For example, we realized the use case order control within the plant. Only one of those machines, only the molding plant, gets the production order from a superior system. It starts the order and then it provides information of the input and output order currently processed to all the other machines. And if, for example, in the buffering machine, a new product enters, the controller of the buffering machine can read up the information from the controller of the molding plant, what is your output order, and by this realize to provide data with reference to the right order now processed also in the buffering machine. Another use case we could realize by this machine-to-machine communication with client and server is line control. That makes line integration easier because all of those machines have the possibility to read speeds, status, for example, failure messages of pre or succeeding machines, and then they can react, for example, go slower, go down with speed or speed up, or even stop one of the packers or things like that. And that allows a smooth line control without any necessary detailed project work because they all provide the same interface and all know where to look on which information about speed, statuses and things like that. So this, for the horizontal integration, a great benefit from WS Suites. And of course, those controllers were connected to a superior system to realize classical manufacturing execution functionalities. This was realized again exemplarily on a software from Siemens, the WinCC Unified platform, where we realized MES functionalities beginning with a production control table, fine production planning in an order overview. So this window allows to plan production orders. 2 are currently running, 2 others already planned, and give this information down to the leading machine that will start the order, in this demo case, the molding plant. When the production order started, of course, the OPC UA interface, now from servers, from the machine controllers to the client, the MES solution, WinCC Unified here, allows then to acquire data with reference to the currently running production order. What could this be used for? For example, of course, a line visualization. We did this here, pretty simple. Pictures, current speeds of the machines or the fill factor of the buffering system, and a Gantt chart that shows the statuses in the last hours of production or last minutes. Here you can zoom this. Might be very interesting to see how good is the line controlled and running, how many errors occurred, and also of course the possibility to calculate performance indicators with reference to the current order or articles in history or time slots in history or things like that. Here realized according to OEE factors and OEE concepts. Then in more detailed, we have views on single machine data, the statuses, some counters or measured values, the temper index, for example, in the temper, that can be also looked more detailed on for the tempering zones of this tempering machine. If we take a look at the molding plant, I would like to present you another very important approach of WS Suites. In WS Suites, we followed a component-oriented approach. A machine may not only be one server representing a machine, this server may also represent components of this machine. So the machine consists of several components that may again consist of components. Here realized exemplarily for depositor component, vibration station component, or cooling station. And those components have their own state information, their own counters, measured values to be provided, and this makes it pretty easy to model, to set up the information model for complex line or machine constellations. Just a short look on the windows for the buffering system with an historical trend of the buffer filling degree, or the packers again state current speed. This packer is not packing right now because there are missing goods to pack. To go back to the other windows, of course, alarms or warnings may be visualized. This is state-of-the-art information, and what might be also interesting for the evaluation of historical data, I will have a look into the order overview now historically, and we can set an order that has already produced before. These are old orders with the same numbers, or this order 1, and you can see, well, this was not the best OEE here, because of course in the simulation, of course, we wanted to have some errors to show some differences in the efficiency calculation. So here classical MAS functionality realized that now, based on WS suites, can very easily be connected to the standard interface of machines and quickly be implemented and run up and realized to use. Of course, we are sure that a standard interface based on OPC UA that we provide with WS suites, we recommend to use with WS suites, will have a lot more opportunities for the future. Any device in the Internet of Things world may connect to an OPC UA server and use the information there. You can think of cloud services, predictive maintenance services, or even artificial intelligence services that get a lot more information out of the required production data that we can imagine today. I thank you very much for your information. And if you have further questions, of course, just ask me about the WS Suites project.
At the end of our presentation, I'd like to summarize your benefits of the Weihenstephan Standards. Our Weihenstephan Standards Suites offers you predefined and standardized data content, a uniform communication interface based on OPC UA. It brings along all our WS software tools and significantly reduce effort for project planning and implementation. So our WS Suites saves you time and costs in IT integration. For more information, just contact us or visit our website www.weihenstephan-standards.com. Thank you for your attention.